If a question arises, how do we check whether a number is even or odd? Most of us already know the answer. If the number is divisible by 2, it is even. Otherwise, it is odd. So in C language, we directly write a program using modulus operator. But is this really the only way? What if there are faster, smarter, and more logical ways to do the same thing? And what if someone says, you are not allowed to use certain operators? Let's find out. Welcome to this playlist, One Problem, Many Logics in C language. Here, we don't just write programs, we understand how logic actually works. Let's start. Problem statement. The problem is simple. Check whether a given number is even or odd. But every time, we will use a different logic. Logic 1. Modulus operator, percent. The most common logic, using the modulus operator. The modulus operator gives the remainder. If a number gives remainder 0 when divided by 2, then the number is even. If number %2 equals 0, printf even, else printf odd. This is simple and best for beginners. Logic 2. Bitwise AND operator, AND. Now let's move to a smarter logic, the bitwise AND operator. In binary representation, every even number ends with 0, and every odd number ends with 1. So when we perform bitwise AND with 1, we only check the last bit. If number and 1, printf odd, else printf even. This logic is very fast and commonly asked in interviews. Logic 3. Division logic, integer division explained. Now imagine this condition. You are not allowed to use the modulus operator. So what can we do? We use division logic. In C language, division of two integers always gives an integer result. That means any decimal part is automatically removed. So when we divide a number by 2 and then multiply it again by 2, if number divided by 2 multiplied by 2 equals number, printf even, else printf odd. If the final value becomes the original number, it means no decimal part was lost. That happens only for even numbers. This logic works because of integer division behavior in C. Logic 4. Loop subtraction method. Now, let's understand the problem mathematically. We keep subtracting 2 from the number again and again. If the number finally becomes 0, it is even. If the number finally becomes 1, it is odd. Int n equals number, while n greater than 1, n equals n minus 2. If n equals 0, printf even, else printf odd. This logic clearly shows how even and odd numbers behave internally. Logic 5. Left and right shift operator, rocket. Now, here comes a very interesting and less known logic, using bit shifting. When we right shift a number by 1, it is equivalent to dividing the number by 2. And when we left shift it back, it is equivalent to multiplying by 2. If number right shift 1, left shift 1 equals number, printf even, else printf odd. If shifting right and then left gives the same number back, then the number is even. This works because odd numbers lose their last bit during shifting. This logic is advanced and shows deep understanding of bits. Logic 6. Without any arithmetic logic, smart approach. And now, a smart and different approach. We stored 2 strings, even and odd, inside an array. Char star result array equals even, odd. Printf %s, result, array, number, %2. Here, the number itself decides which value to pick. This logic forces you to think differently and improves problem-solving skills. Final comparison. So which logic should you use? For beginners, modulus operator. For interviews, bitwise and shift logic. For understanding C behavior, integer division logic. For fundamentals, loop subtraction. The best logic depends on the situation. If this video helped you think deeper, press the like button. Subscribe for more logic-based C programming videos. Keep learning and keep coding.